Good morning, everyone. First of all, I would like to thank the organization for inviting us to this really nice event. We're very pleased to be here and show you our project, H2 project, H2 Ports project that we are developing in the port of Valencia. We are very proud of this project that is one of the first applications of hydrogen in a port environment in Europe. And yeah, I hope you enjoy the presentation. First of all, allow me to introduce myself. I work in Fundación Valenciaport, that is the research center related with the Port Authority of Valencia. We do research in port and maritime related topics, merging together different actors in the port community, such as universities, institutions, companies, industry, terminals. And we try to find solutions for their current challenges, not only in sustainability topics, but also in many others, such as digitalization, connection of the port with the city, and so on. We belong to the Port Authority of Valencia, but we work with many others port authorities in the world, and we have performed projects in Latin America, Asia, and all over Europe. The Port of Valencia is located in the east coast of Spain, and we have a privileged location, as we are the first and last port call for many shipping lines that operate in the Mediterranean area. We distribute goods around 2,000 kilometers, and we work with cities all over Spain, Southern Europe, and Northern Africa. 40% of the goods that are imported or exported from Spain go through the port of Valencia. And we are connected with more than 1,000 ports throughout 100 lines of the main shipping companies. So this is a very good spot to try hydrogen technologies and to introduce hydrogen in port technologies. Our project is called H2 Ports project, and is devoted to be the first application of hydrogen technologies in daily port operations. We are going to test two handling machines in two terminals in the port of Valencia. One of them is a rich stacker that is going to be tested in the Mediterranean Shipping Company in terminal in Valencia. And the other one is a yard tractor that is going to be tested in the Grimaldi Ro-Ro terminal also in the port of Valencia. Due to stowage laws, these machines are not allowed to go out from the terminals, so we had to develop a solution to provide hydrogen to these machines within the terminals. So for that reason, we needed a mobile hydrogen refueling system that has been developed specifically for this project, and we have already there. The total budget is 4 million euros and is fully covered by the hydrogen and fuel cell joint undertaking, that is the financing branch of the European Commission to support hydrogen projects. These are the partners of the project. It is coordinated by us, the Fundación Valenciaport, and is fully supported by the Valencia Port Authority. We have research institutions on board, such as the National Spanish Center for Hydrogen, Centro Nacional del Hidrógeno, and also Athena, that is an Italian research center, and is in charge of the development of the yard tractor for Grimaldi. We have different industrial partners, such as Carburos Metálicos, that belongs to Air Products and is the provider of the green hydrogen that we are going to use in the project. Hyvolution, that is the manufacturer of the rich stacker that is going to be tested in the Mediterranean Shipping Company terminal. We have Ballard, that is the provider of one of the fuel cells that is going to be installed in the yard tractor. And we have Enagas, that is the Spanish TSO, that has a lot of experience in providing gases in port areas. And we have also the most important partners are the end users. At the end, we can do this project because these terminals are willing to start operating with hydrogen, and we have on board the Mediterranean shipping company, Terminal Valencia, and Valencia Terminal Europa, that is the Ro-Ro terminal of the Grimaldi Group. The project started back in 2019 and has gone through many difficulties, some of them external, as you know, the pandemics and the supply crisis, and some others related with the difficulties of starting a new project, a new technology that also comes with some delays. Indeed, the project has extended for an additional period of 1 year. So now it's going to finish in December 2014. And currently we are in a very exciting moment because we have finalized the development phase. So we have already ready the hydrogen refueling system in the Port of Valencia, and we are expecting the machines to arrive in a 1 month period. I mean, probably at the end of March, we will be able to have all the system working in the port. We are going to start this piloting period in March, and we are going to test the machines for a period of 2 years in daily operations, completely integrated in the normal operations of the terminals in the port. Now I'm going to talk about the main pieces of this project. The first one is the hydrogen supply solutions that we developed. This has been developed by the Centro Nacional del Hidrógeno, the Spanish research center. And it's composed by 2 parts, one fixed part and one mobile part. The fixed part is composed by a buffer tank that is able to store hydrogen at low pressure, up to 40 bars. It's able to, we missed a bit, okay. It's able to store up to 150 kilos of hydrogen. 150 kilos is around 3 days of operations of 2 machines, just to have this figure in mind. And we have a compression station in order to increase the pressure from the low pressure tank to the high pressure mobile system that you can see in the picture in the downside. This compressor increases the pressure of the system up to 450 bars, as the machines are going to operate at 350. We have selected a layout of a storage cascade. We have a low pressure storage of 300 bar in the mobile part and a 450 bar because it's more energy efficient to do this to pressure level discharge. And with that, the system is able to reach a maximum flow rate of 3.6 kilos per minute. This means that we will be able to recharge the machines in around 15 minutes. The mobile part is able to store up to 60 kilos of hydrogen and delivered to the terminals on a daily basis. Here are some pictures of this HRS, the mobile part, the deposits that are in the mobile part, and the compressor. And we have here some pictures of the dry run that we performed a couple of weeks ago to try and to test ourselves on how are we going to provide this hydrogen on the terminals in a real day operation. We received the first load of hydrogen just a couple of weeks ago, so we have already the hydrogen there, and we are just waiting for the machines to arrive. This is one of the machines that we are expecting to arrive very soon. One is the reach stacker. The reach stacker is a machine that is designed to move, to handle containers very quickly and in short distances. It has been developed by our partner, HHLA, completely from scratch. This is a completely new design. And you can see in the left side of this render the hydrogen deposits. They are very small, but I guess that you can still see them. And well, the main objective is that when this system are in operation, we will be able to reduce 128 tons per year of CO2 equivalent. The rich stacker has two Nuvera fuel cells of 45 kilowatt each, and the expected consumption of hydrogen would be around 32 kilos per in 2 8-hour shifts. The other machine is the terminal tractor. These are tractors that are going to move the platforms of the trucks arriving to the ports and get them into the vessels. This is developed by Athena, but instead of being a specific design, this is a retrofit from a diesel tractor. So this has been really a challenge to adapt all the hydrogen systems into a quite reduced space. Now they are commissioning the fuel cell. They are in the last steps of that stage, and we expect to have them by the end of March. The fuel cell is a Ballard HD70 with 70 kilowatts of operation, and the consumption is around 14 kilos of hydrogen in one shift, around 8 hours. The system is complemented with a battery pack in order to adapt the performance of the system to the functioning profile of the yard tractor. It needs to change speeds really quickly, and so the system is really challenged to provide a lot of power in small periods of time. And for that reason, the combination of the fuel cell and the battery pack is key to be able to deliver the power that is expected. Additionally, we are going to do some studies around the project. The main outcome is to have the data, how the systems are working on a daily basis, in order to define the commercial strategies and the studies and the business models that will be able to facilitate the introduction of hydrogen into the port operation sector, into the terminals. We are going also to focus on the current regulatory state and propose new regulatory measures that could ease this introduction. We want to increase also the awareness of using hydrogen in a terminal. We want to also to study the human factors that are around that topic. And we're going to publish all these studies as long as the project starts this piloting period. We are quite active in social networks and in our webpage, and from now on you can follow the news and the developments of this project in our platforms. And thank you very much. I will be pleased to answer any questions that you may have.